So my name is Shlok Kyal and I work as an associate application developer at Fujitsu. And today I am going to give talk on how to upgrade replication clusters without downtime. So let's get started with the talk. So today's agenda is going to include introduction. So I will be talking about what is upgrade and what different types of replication are present in Postgres, and yeah, I will also talk a little bit about logical replication. Next, I will talk about the steps to upgrade the replication cluster until PG16. How we used to upgrade replication clusters. Then I will talk about the new logical replication features which were introduced in PG17. Then I will talk about upgrading the replication cluster for PG17 and onwards. So using the new features which were introduced in Postgres 17, I will show that how it has improved the upgrading of replication clusters. So let's start with the introduction. So first of all, what is upgrade? So upgrade refers to the process of moving database to a newer version. So every year a Postgres community releases a major version, and it supports it only for 5 years. And each major version includes new features, new performance improvements, it introduces new tools. So that's why to take advantage of that features, we should upgrade our clusters, Postgres clusters in regular intervals. So moving on, so how to upgrade the clusters? So do installing the binaries only will do the upgrade? The answer is no, because major version releases cannot understand the old data directories, because in every release there can be changes in system catalogs, there can be changes in wall formats, due to which the newer major version cannot access, cannot understand the old data directory. That's why we need a different method to upgrade. So what we use is, we use PG upgrade in Postgres to upgrade our clusters. So PG upgrade is a built-in tool in Postgres, and it is around 7 times faster than dump and restore, according to the analysis done by Bruce. And why is it like 7 times faster than dump and restore? So PG dump actually dump the data in form of SQL commands. So if we want to recover our data, we just need to run that SQL commands, that script of SQL commands, and it will get restored. But in case of PG upgrade, there is some assumptions. Like in PG upgrade, we assume that only system catalogs are changed between major version releases, and the table file formats are preserved across major version. So when we run PG upgrade, it runs PG dump and PG restore in background for the system catalogs, whereas the table file are copied using this file level system calls like read, write, etc. So next, let's discuss about the weaknesses of PG upgrade. So PG upgrade requires the instance to be stopped, because while upgrading, we do not want user to interfere with some commands, or don't want some process like auto vacuum and all to interfere during this process. Also, PG upgrade cannot migrate a logical replication slot and physical replication slot during the upgrade till PG16, but new feature was added in PG17 where this logical replication slot can be migrated when the instance is upgraded. So I will talk about it in later slides. Next is that PG upgrade can break the streaming replication cluster. So basic requirement of streaming replication cluster is that both the instances of the cluster should be on same Postgres major version. But PG upgrade can upgrade a single instance at a time. So that's why upgrading a instance of a cluster can break the streaming replication cluster. So what we can do in that case? Like, can we do something like that this replication is not broken? So we can use a logical replication in that case. We will be discussing this in later slide, why we can use logical replication. First, we will be going to understand the types of replication in Postgres. So basically, there are two types of replication in Postgres. One is streaming replication and other is logical replication. And they mainly differ in the type of data they send during replication. So let's take an example. Here, there is one application which sends query to the upstream, and upstream is replicating to the downstream. Suppose an insert query is sent. So in case of streaming replication, what data are sent? So in case of streaming replication, the exact wall records are sent from the upstream to the downstream for the replication. Whereas in case of logical replication, these wall files are first processed. They are converted into some meaningful replication messages. Then after decoding that, it's sent from upstream to the downstream for the application. So now let's see more differences between streaming replication and logical replication. So for naming convention in streaming replication, we upstream we call upstream as primary and downstream as standby. In logical replication, we call upstream as publisher and downstream as subscriber. And what content they actually send? In case of streaming replication, they send exact wall records, where in case of logical replication, they send the decoded replication message.
Replication messages,
Yeah.
is it in SQL format or?
No, it's not.
What do you mean protocol or format?
So it's not SQL messages. It's kind of summary of data, you can say, like insert then some data. Means it's not exact SQL commands which are sent. So who initially synchronized the data? In case of streaming replication, we set up the standby node using PG based backup. That tool only does the initial sync for streaming replication, whereas in logical replication, when we create the logical replication, at that time only a background process is spawned, and that does the initial sync. What is the replication target for streaming replication? The replication target is the whole database cluster, whereas in case of logical replication, it is per database. We have to create logical replication per database. What downstream can do? In case of streaming replication, we can only do read-only queries on the standby node, whereas in logical replication, we can do both read and write on the subscriber node. For environment, streaming replication requires the OS as well as the major version of Postgres to be same on both the instance of the cluster, whereas in case of logical replication, there is no such restriction. Streaming replication is mainly used for backup purpose, whereas logical replication can be used for backup purpose as well as other purpose, because in logical replication we can send specific columns as well. We can apply row filter while replicating. So yeah, now let's see the uses of logical replication. So how can we create publication? We have to run this create publication command on the publisher node on which we want to create the publication. So yeah, and then we have to run the create subscription command on the subscriber node to create subscription, and to fetch to subscribe to that particular publication that we created on publisher. Now let's talk about the replication slots. So replication slots are an object which ensures that the WAL files are not removed. So basically, in Postgres, there is a mechanism of WAL recycling. So this doing WAL recycle, it archived the data. So once, so what happens like this logical replication slots or physical replication slots keep the value of the LSN up to which the replication has been done from the upstream to the downstream. And whenever a check pointer is run in the background, so it checks all the replication slots for that LSN value, and it ensures the WAL files which are not yet replicated are not deleted. So the main purpose of replication slots are this. Now there are basically two types of replication slots. One is streaming replication slot, and other is logical replication slots, and they are used in their corresponding type of replication. Also, logical slots contain an output plugin which is used by logical decoding. Now let's see how we upgrade replication cluster till PG16. So before going to that, we will see the challenges we saw till now in upgrading replication clusters. So first challenge we faced that the major releases can change the layout of the system catalogs. There can be some addition of columns. There can be change in the data types of column. And also major releases can change the WAL records. And yeah, so also major version, a new major version upgraded instance cannot access the old data files. And streaming replication cluster does not work after one of the instances upgraded. So now let's see why we can use logical replication for upgrades. So logical replication works across major version. So even if one of the instances on a different major version, logical replication can happen and continue. Changes in WAL format do not affect logical replication because these WAL files are first decoded and then sent. So that required information are only sent. So once we upgrade a instance, after upgrade also logical replication can identify and replicate changes. And hence, thus because of all this, it can be used to reducing the downtime. Now let's see the steps to upgrade streaming replication cluster, which were used till PG16. So for this, I will be taking example for upgrading the cluster from PG13 to PG16, and I will be creating primary on node 1 and standby on node 2. And during this process, any concurrent activities are allowed. And we have to make sure that WAL level is equals to logical on the primary node. So let's get started. So here you can see we have initial setup in PG13, and we want to upgrade it to the setup in PG16. So here first step would be, we will be creating replication slots on all databases. Then we will create publication on all tables for all databases. Then we will wait for the standby to catch up, and then we will upgrade the standby to primary. After that, while we are upgrading the standby to primary, we will keep the note of the LSN value on the primary node. And in fourth step, we will advance the replication slot to that particular LSN value. Then we will create subscription for all databases on subscriber node, node 2. So once this is subscriptions are created, and while creating subscription, we will be using the slots which we created in step 1. And once we create subscription, our logical replication setup is done, and the changes will start to replicate from the point, the LSN value that we advance the replication slot to. Then we stop and upgrade node 2. So node 2 is upgraded, and now here comes a little tricky steps. So we upgraded the subscriber. So while till PG16, the upgrade of subscriber is not supported. Like the subscription related informations are not preserved after the upgrade. So the list of tables in the subscription and the replication origin data are not preserved. So we need to truncate all the tables and recreate subscription so that logical replication is again set up between both nodes. And while recreating the subscriptions, the all data are copied again from node 1 to the upgraded node 2. So once this is done, we stop the node 1, and since all data are already present on node 2, upgraded node 2, so we will just take the backup of, we will create a standby of node 2, and hence the streaming replication will be set up, upgraded streaming replication will be set up, and we just need to drop the replication slot on upgraded node 2, and we get an upgraded streaming replication cluster. Now, let's see what are the problems we face during this upgrade. So we saw that we are converting the streaming replication to a logical replication first. So we need to create slot, we need to advance the LSN for every publication. And also during the step 7 and 8, we saw that the subscription related information are not preserved. So we need to drop the subscription, we need to recreate the subscription. Also we need to truncate all the data from all the tables. So this process is complex and can be time consuming. So these were the problems in upgrading streaming replication clusters till PG16. Now we will see the steps to upgrade logical replication till PG16. So there is a same setup, like we have initial setup of logical replication is PG13, and we want to upgrade it to a logical replication setup in PG16. So let's get started. So first of all, we will disable all subscription on node 2, and then we will stop and upgrade the node 1. So while this node 1 is upgraded, so then after upgrading node 1, we will recreate replication slot, because there is a limitation till PG16 that the replication slots are not migrated when the publisher instance is upgraded. So we recreate replication slots, then we stop and upgrade the node 2, and once we do that, we will create some, so during the period the subscriber is upgraded, there can be case that some new tables are created on the publisher side. So since logical replication do not support DDLs, so we need to define those tables on the subscriber side after the upgrade. Then we will truncate all tables and recreate the subscriptions, because of the same issue that I discussed earlier, that subscription related information are not preserved during the upgrade of subscriber. After doing this, logical replication will be set up in the upgraded instances. Now let's see the problem we faced during this. So logical replication slots are not preserved when they are when the instance is upgraded till PG16. So we need to recreate the logical replication slots after the upgrade. Also, subscription related information are not preserved. So let's see the new logical replication features which were introduced in PG17. So migration of logical replication slots. So earlier the logical replication slots were not migrated during the upgrade, but with introduction to this feature in Postgres 17, now when an instance is upgraded, so while PG upgrade is running, it will go through the list of slots on the old cluster, and it will store that information and create new logical replication slot on the upgraded instance. So with the information that was fetched during the from the old cluster. And yeah, after the upgrade of publisher, we just need to change the connection string on the subscriber side to point to the upgraded publisher instance, and after doing that, the logical replication can continue seamlessly. Now, second feature which was introduced is that it preserves subscription related information during upgrade. So till PG16, only subscription related subscription metadata was preserved, like subscription name, connection string of the subscription. Those data were only preserved, and also the list of relations, their states, and replication origin data were not preserved. So just simply re-enabling the subscription after upgrade till PG16 will lead to loss of some data. With introduction to this feature, so the states of tables are preserved and replication origin data are also preserved. So states of tables are stored in PG subscription rail. So that catalog table data are preserved during the upgrade. So this task is done by the PG dump during the execution of PG upgrade command. So there were some new SQL APIs which were introduced to achieve this task. Now let's talk about talk about the new tool which was introduced in PG17, that is PG create subscriber. So PG create subscriber converts a physical standby to a logical subscriber. So it ensures, so how does it do that? So it first ensures that this standby is caught up to a certain point. Then after that certain point, it will create subscription on the standby. So basically, PG create subscriber, we can say that PG create subscriber is used to convert a streaming replication cluster to a logical replication cluster. So this is run on standby node. So this is a format for writing PG create subscriber command. So there is a database option. So we can use this database option multiple times. So this will run PG create subscriber on that database only, and with the data directory we can PG data, we can specify the data directory of the standby server, and with publisher server we provide the connection string of the publisher. So what was the motivation behind this? So suppose there is a streaming replication setup. So now we want to create a logical replica. So how do we create? We run a create publication command on primary, and we create a new node and run a create subscription command with copy data on the new node. So when we run this copy data we create subscription with copy data equals to on, background process runs, and it runs copy command for each of the tables in the subscription to copy the initial data. So suppose our database is very large. So what will happen in that case? So let's see the limitation in that case. So it will take a longer time to do the initial synchronization of data. So copy command runs per table, and execution of this initial synchronization is proportional to the number of tables in the subscriber. And also there is one more limitation, like suppose our cluster is very write heavy, and our instance, so there we have created logical replication, and there is initial synchronization is happening. And since this copy command is taking much time, there can be case like the replication slots are already present on the subscriber, publisher, and it will be holding wall. And while it is holding wall there and the system is very write heavy, the wall can keep generating, and it is preserved since that changes are not still replicated. So there can be the case that instance might get, the disks of the instance get filled up. Yeah, so this is one more problem. So basically PG create subscriber resolves this, and here I have done some performance testing. So between the logical replication setup and the PG create subscriber setup. So the left bar graph is for the logical replication setup. For that case, the start time is when we start when we start running the command of PG subscription, and it ends at the time when the synchronization of all the tables is done. And for the case of PG create subscriber, I have taken the time from the start of the setup of the standby till the end of the execution of PG create subscriber command. So this data is done on 10 tables, and each table is equals to the size of the data which is on the x-axis. So let's talk about the 5 GB data. You can see, like with this PG create subscriber approach, the time is around, it is taking around, means time for logical replication is around 7 to 8 times as compared to the PG create subscriber. So with introduction to PG create subscriber, the initial setup time of this logical replication is reduced by a larger amount, as you can see. So now let's talk how PG create subscriber work. So suppose there is a streaming replication setup initially. So first step is that we verify the publisher node and the subscriber node, that means we check some gugs to make ensure that this conversion can happen and will not break at a later point. So for that, this verification checks are done. After that, we create publication and replication slot for all tables, for all the databases which are provided while running that PG create subscriber command. Now, we set the recovery target LSN. So after creating replication slot, we get the LSN value on the primary node, and we note that, and we set that in recovery target LSN, and in recovery target action we will specify promote, and then we will restart the standby node. So what happens, like this specifying these gug values will ensure that after restart the standby is synced up to that LSN point and is promoted. So after this, we just create subscription on the standby node, and while creating subscription, we made ensure that we use the slots which we created in steps 3, and we set the copy data equals to off because the initial data is already copied during the streaming replication, and we do not enable the subscription while creating it. On step 7, what we do, the LSN value which we got during step 3, we advance the replication origin on the standby to that point, and after that we just enable the subscription. So once we enable the subscription, logical replication is set up between them. So that's how PG create subscriber work. And yeah, so we need to also update the system identifiers. So in Postgres, every instance has a unique system identifier, but when they are in streaming replication, the system identifier on both are identical, and we use this check to check whether both instances are in streaming replication or not. So, but in this case, we have already converted into a logical replication, so we need to update that system identifier. So we do that step, and finally that setup is completed. Now let's see, using these features, how we can improve our upgrade process that we discussed earlier. So in this case, I am upgrading the cluster from PG17 to PG18+, because these new features were introduced in PG17 and can only be used if the the old cluster is PG17, and we upgrade it from PG17 to a later version of Postgres. So suppose now we have a streaming replication cluster setup in PG17, and we want to upgrade it to PG18+ setup. So what step we will follow? So first, to convert this streaming replication cluster to a logical replication, we will just run pgcreate subscriber command, and then we stop the node 2 and upgrade the node 2. So once this is done, the logical replication is automatically set up after upgrade, because subscription related information are now preserved during the upgrade, and we don't need to do that additional steps. And on node 1, we just stop the node 1, and since all data are already present in the upgraded node 2, we will make a standby for that, and and we will drop the subscriptions on the upgraded node 2, and this the streaming replication cluster is upgraded. Now let's see how these new features can simplify the steps to upgrade logical replication cluster. So initially we have set up in PG17, and we will be upgrading it to PG18 setup. First we will disable all subscriptions on the node 2, and then we will stop and upgrade the node 1. So after the upgrade, since logical replication slots are migrated from PG17, so we don't need to recreate that replication slots in the upgraded instance, and we just stop and upgrade node 2. And in this case also, we don't need to truncate and recreate the subscription, because subscription related information are preserved. But we just need to define the tables which were created on the publisher during the process of upgrade of the subscriber node. So once we create that, we just enable and refresh subscriptions for all tables, and that logical replication setup is done. So going to the summary, we saw different challenges while upgrading replication clusters. Then we talked about different features which were introduced in PG17, and we saw that with this feature how the downtime can be reduced during the upgrade of the streaming replication cluster, and also how the process of upgrading logical replication cluster can be simplified. So, yeah.
Performed in replications, within replications.
Yeah.
Prior to version 7.
Yeah.
It's been taken care in version 17 to 18 internally. So all updates and these things happen
Yeah.
later. Is that the case?
Yeah, you can say. So means that truncate and all things are not done. Means there is one catalog table called PG subscription rail. So basically that information means till PG16 that information which was stored in that catalog table were not preserved during the upgrade. So means from PG17 that data is preserved. So we don't need to follow that steps only because that data is only required to continue the replication.
So conversion is seamless and the amount of time that it takes to copy data is not.
Yeah, correct. Means in case of PG16, the copy data means the copy of whole data happened again due to recreation of subscription. So in the case of PG17, this time is reduced because we don't copy data again. The replication continues from that point only where it stopped before upgrade.